There are many different ways we can draw on our screen, different ways we can generate graphics. We have tried some of them. For example, sometimes we have been drawing a line from left to right and the vertical position was changing according to some function, maybe noise, maybe random. We have also tried drawing something here using the sine function, so that this was like drawing dots or drawing lines on the screen, and slowly an image was appearing. This time let's try a different approach, and we can create a texture. We can draw every single pixel on the screen. And how can we do that? We have seen how to make a while loop inside a while loop. So we're going to run through every pixel on the screen. We will start here from the left, 0, 1, 2, 3, all the way up to width. And for each of these, we will do the same for, this was our X value. We will do the same for our Y value. So we will go from 0, 1, 2, 3, all the way to height. So for each horizontal pixel, we will draw all these vertical pixels. How many pixels are we gonna draw? If we have here a screen size of 500 times 300, our width here, this width is 500. The height, I left here my T. Our height is 300. So the total amount of pixel is 500 times 300. That means 1, 5, and 4 zeros. We are going to be drawing 150,000 pixels, but nothing to worry about because we don't have to draw them one by one, but the computer is going to do that for us. So let's start doing our first while loop. Float x is 0, while x is less than the width. Then increase x by 1. So this line here is going to be executed 500 times. And each time this line is executed, here we're going to do another loop. We're going to make x go between 0, and then while y is less than the height, then we increase y. So this line here is going to be executed 300 times, this line here, for each of the 500 times. So I guess you can see how many times this is going to be executed. So let's make just a point here, point x and y, and let's set a color. So stroke, let's make it red. So we're gonna, this is a very complicated way to just fill a screen with red color. But of course, we are not going to use all the time the same color. For example, what happens when we use a random value between 0 and 255 for the red component? Now we have this noisy image here. If we remove the green and the blue, it's gonna be black and white. This is gonna look similar to a TV when it loses the signal. Okay, so we have used here one option, which is to use just a random value. What else could we do? We could use also noise. But one way to avoid these lines getting really long and having functions inside functions endlessly, we can get the part which is inside the parentheses out and just use a variable. So this will be my color, and I declare the color in a previous line. I could write both of these in one line, but it's easier to read and change when we have several lines. So we have float color. We're gonna use a map to convert this number, which is a number between 0 and 1, into a number that is between 0 and 255. And inside our noise function, we should add something here like x, for example, x divided by something. We can try x and then see if it's x. You can see it's changing really fast. Vertically, it's not changing. If I divide x by 10, then I start to see some detail. And the larger this number, the slower it will change horizontally. And if I want to also make it change vertically, I could either add here something. For example, I could add here the y value. This is one way of doing it. Or more interesting would be just to have two parameters, x and y, separated by a comma. And now I have this kind of clouds here. Let's try now with the sine function. Instead of noise here, I'm gonna use sin. Well, before that, let me again simplify this. You see this line is getting a bit long. So I can add again another variable here. I'm gonna call it v, like value. And I'm just gonna cut out all this noise expression here. And there I put rb. All these three lines here could be written as one line, but it gets really hard with so many parentheses inside parentheses. I think it's easier to read like this. First, we calculate a value. In this case, it's just a value between 0 and 1, a random value. Then we use this value in the next line, and we try to convert it to a number between 0 and 255. Finally, when we have this value that is a number between 0 and 255, we set the color. So we do this in 3 steps. So I was talking about using here sin or the sine function instead of noise, but it only takes one parameter, so I cannot have a comma here. I'm just gonna maybe add the two values. And remember that the sine function returns a number between -1 and 1. So I have to change this here. And what do we get now? So we get these diagonal lines. Let's make these values a little bit smaller, 50 and 70. Let's see how that changes. So we have this very smooth changing of color. I can multiply this again by other sine expressions. And what do I write here? Just x divided by 33 minus y divided by 63. I'm making this up. I have no idea of what I'm going to get. And now I'm getting strange holes, and there's dark and bright areas here. I hope you can see if I reduce these numbers, the pattern becomes tighter, or it changes faster across the screen. So I'm using now smaller numbers here to divide. So now the pattern becomes, wow, this makes a quite strange effect, don't you think? I keep trying to focus on these dark places, and I see some bright points moving around. Weird. And just finally, let's just add some color. This is very gray, so I can add here the color mode HSB, which allows us to set the hue independently from the saturation and the brightness. So this is gonna be, instead of color, it's gonna be hue, and I will set the stroke like hue, comma. Well, let me add here at the end a value to say our colors are always defined by values between 0 and 10. So now I have to fix this. This has to be between 0 and 10. And these other two numbers also have to be between 0 and 10. So I'm gonna use 0.8 and 0.8 just to see what I get. Wow, this is a very dark image. Of course, I messed up because I wanted to say actually 8. We are using values between 0 and 10. What about now? That's a strange, colorful pattern. So I let you combine here, multiply lots of these sine functions here and change the values, use only x, only y, see what kind of patterns you can come up with. And I'm gonna just add very short line here at the end. We can save the images. If I save, remember we did this some episode. If I write here texture.png, as simple as that. I just run the program, and now the image is saved. So I can go to the show sketch folder, and the texture is here. What is a pity is that every time I run the program, it's gonna delete the previous texture. And I can fix this in one way. I can make up a random name. So I can say here like R&D is random, I'm gonna make a number between 0 and 1 million. And if I convert this to an integer, I get rid of the decimals. Let me show you the difference. I'm just leaving here random, so I'm gonna print R&D. Okay, I have to declare the variable here, float R&D, and you can see here now the number. But it has some decimals, which for a file name to have this dot and more numbers is not so good. So if I just change here, I add int, and then I say this variable is no longer float but int. Now there's no decimals. So I can create images which have this name, like R&D plus dot png. This is concatenating. I'm the number and I'm adding some text behind. This is a good name for an image. So instead of printing, I'm just gonna delete this line. I'm just gonna save the image with this extension. So now when I run the program, and if I go now to the folder, show sketch folder, I have an image here, which is a number.png. Don't go too crazy making millions of images because, well, your folder will be full of images. Better clean up after you're done and just keep the good ones.